Scholars agree that low math achievement has been shown to have a lasting impact on a student's academic and life trajectory. I'm Lydia Rosenbaum, and I'm here to talk about how teachers can help. Sadly, students have been given the impression that the fast recall of math facts is what it means to be good at math. This has resulted in students who are disaffected, anxious, and labeling themselves as not a math person. In my grade 6 class, I observed that many students were struggling with recalling multiplication facts fluently, blocking success in more complicated work. Luckily, there is much we as teachers can do to support students' understanding of number relationships alongside math fact fluency. This video will explore this challenge by reflecting on the relevant research about developing math fact fluency. I will share 3 research-based teacher moves that can help students master the fundamental skills of multiplication while meeting the diverse needs of all learners. Research indicates that the development of number sense is critical to the continued success in higher-level mathematics. Studies show that low math achievers have been set on the wrong path, often from a very early age, of trying to memorize methods instead of interacting with numbers flexibly. Although memorization is useful, drills without connection to concepts can impede the understanding of more sophisticated content. Though many of us learn this way, research tells us that the best way to cultivate math fact fluency is to use strategies that develop flexible and conceptual thinking. The approaches shared here are not just remedial. They aim to help students identify what they know and to teach them to reason their way to building new knowledge, instilling confidence in their own abilities. This first move centers on the strategy of doubling and halving as a pathway to multiplication fact fluency. To implement this move, the teacher introduces regular and brief whole class mental math sessions. The teacher begins by sharing a number orally, and then has consecutive students continue by doubling subsequent numbers. Students can record each number to use as an anchor to ensure accessibility for all learners. As numbers get more complex, the teacher asks the students to share the strategies they use to compose each number so that they can learn from each other. Once students are comfortable doubling numbers, teachers can connect the doubling task to multiplication. Students may feel anxiety doing mental math as they work with higher numbers. To mitigate this, it is important for the teacher to allow students to ask their elbow buddies for support. This move provides accessible patterning strategies to help students commit multiplication facts to long-term memory. Studies show that once students develop math fact fluency, mathematical facts are transferred to long-term memory, freeing up working memory resources that are critical to advancing mathematical learning. To implement this move, teachers explicitly explore times table patterns in a class-wide format, followed by a brief practice. Though the order in which the times table patterns are introduced are not fixed, grade 6 students have already been exposed to their 9 times tables and find it motivating to begin at this level. Many of us were taught at least one 9 times table pattern. One example is Magic Nines. This strategy reveals that in every product for factors up to 10, the digits can be added together to make 9. This approach has been shown to engage children in multiplication by revealing patterns and building a conceptual framework on which they can map multiplication facts quickly. To avoid students memorizing only the tricks, teachers can ensure that students are given the opportunity to explicitly make their multiplication reasoning visible through regular math discussion and conferencing. This move entails giving students an opportunity to practice multiplication in a game format. Scholars agree that games serve to develop understanding as well as increase motivation to learn math, simply because it's pleasurable. However, much classroom practice is still performed purely through worksheets and timed tests. Teachers can assign small groups, heterogeneous in ability, where once a week, for a minimum of 30 minutes, students play math games. The teacher would monitor and switch games, moving to higher levels of complexity as students have exhausted each one. To ensure that the games are always in the student's zone of proximal development, the teacher plays with the group to determine the level. For example, 4 in a row is a game that helps students practice factoring. After a game session, the whole class would come together for a quick conversation about the games and the strategies they used to figure out the math involved. It is essential that children develop competency with each times table before moving on. As such, it's vital that teachers track which children are using strategies to find solutions and which students need additional support. Anecdotal records and regular assessment are crucial to ensuring mastery, and progress should be paced accordingly. The 3 moves shared here work together to build math fact fluency through math conceptualization and math discourse as a means for deep learning. Mathematical discourse is a critical practice that helps students make sense of problems and persevere in solving them by constructing viable arguments and critiquing the reasoning of others, learning from each other's mistakes. Scholars agree, by building relationships with numbers through mathematical reasoning, teachers pave the way for powerful math learning, which is proven to have a lasting positive impact on students' academic trajectories.